In this video, we are going to tackle this problem where we have to find the sum of first n Fibonacci numbers. Now, what is a Fibonacci number? Fibonacci number is a sequence of numbers such that each number, each of the sequence numbers in that sequence is sum of the previous two numbers. So, for example, if you see here, then so let's say the first Fibonacci number is 0 and the second Fibonacci number is 1. Then this third Fibonacci number will be the sum of the previous two. So 0 plus 1 is equal to 1. Then 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5. So you can understand that 34 is 13 plus 21. So each of the numbers is sum of the previous two numbers. That is how it works. And from where to start, actually it depends. Different people start from different places, but some people say that first and second both Fibonacci number is 1 1. Some people say that first Fibonacci number is 1, second Fibonacci number is 2, and then from third they keep on adding these things. But we will take this standard way in which we will assume that the first Fibonacci number is 0, the second Fibonacci number is 1, and the third Fibonacci number onwards is the sum of the previous two. Okay, so in that manner, if we decide, then what is the sum of the first Fibonacci numbers, which means that if 0 1, right, and then we are going to have 1, and then 2 3, right, 5. So in that sense, you can understand that if we say that n is being passed to the solution, which means that what is the sum of the first three Fibonacci numbers? First three Fibonacci numbers is 0 plus 1 plus 1, and that's why it is 2. What is the sum of first 5 Fibonacci numbers? 3 plus 2 plus 1 plus 1 plus 1, right? So this is going to be 3 to 5 to 7. Okay, so 7, and so in that same manner, what is the sum of the first 6 Fibonacci number? 12, and in that manner it will keep on continuing. So the idea is that if this way Fibonacci numbers are defined, then you have to find the sum of the first n Fibonacci numbers. So you can pause the video right now and try to implement the solution such that when I pass n, it should return me that sum, whatever I want. So now let's have a look at the solution of this question. So what we are going to do is that in the solution file, we'll start implementing this sum of first n Fibonacci numbers. The passed argument is n, which means that in this case 6 is going to be n. Just let's try to log it, and we will see that this is 6, right? Now we have to create a solution where we have to find the first n Fibonacci numbers and then sum them. But before we do that, first of all, let's find let's create a function which can create a particular Fibonacci number. So for example, if I write Fibonacci, I want to get Fibonacci, third Fibonacci or fifth Fibonacci, then I should get it. Okay, so for that, let's try to create a function Fibonacci where if you pass a particular n, then it should give you nth Fibonacci number. So the first two are pretty simple. We know that if n is equal to 1, the first Fibonacci number we have to return it as 0, right? The second Fibonacci number we have to return as 1. From the third one, we have to understand how to do it. So let's firstly implement a recursive solution where I can say that Fibonacci 1, 2, they are defined as 0 and 1. After that, if I want to find the third Fibonacci, then that will be summation of first Fibonacci and second Fibonacci. If I want to get the fourth Fibonacci, then it will be summation of second Fibonacci and third Fibonacci, which means that in general nth Fibonacci will be summation of n minus 2 2th Fibonacci and n minus 1th Fibonacci. Understand? So the most recent one and the second most recent one. Now we can clearly see that now if I try to let's say print Fibonacci n, okay, then I can see that I am getting 5. So 1 2 3 4 5 6. So I am getting the 6th Fibonacci. 1 2 3 4 5 6. The 6th Fibonacci is 5. So that looks fine. So now I have got the nth Fibonacci. Now I am interested in finding the summation of the first n Fibonacci. Okay. So obviously let's see. So let's say sum is equal to 0, and then we are going to iterate over so let's say from first Fibonacci to nth Fibonacci, and you can use any variable. So let's say k, that is fine. So if k denotes the kth Fibonacci, where k varies from 1 to n, then I want to sum Fibonacci k all the way. Okay, and then finally we are going to return that sum. So this is how it is. I started with 0, and in that first Fibonacci to nth Fibonacci I have added all the Fibonacci numbers and then returned that sum. Now this should give me the answer. So in the case of 6 it is 12. Okay, fine. In case of 4 you can see that it is 0 1 1 2, which means that 2 and 2 4. Okay, in case of 5 it is giving me 7, so that 3 is extra. So that is fine. It looks like it is working. Now just to show that this thing is working fine, let me have a look at the other test cases also. So this link I'll provide in the description on YouTube, but for now let's take this and run it through the entire solution, and done, which means that no assertions are failing, which means that all our solutions for these test cases are working correctly. Okay, so this should be test 2 3 4 anyways. Yeah, so the idea is that since this is working fine, which means that our solution is done, but let's take a particular solution, let's say solution 6 for now, and the idea is that can we somehow optimize it further. So we know that solution is working, but this 6th thing is 12, that is fine, but can we optimize this solution further? So you can see that the main problem here is that, let's say solution 6, so 6 from 1 to 6, so let's say you are trying to find the Fibonacci of 5. In order to find Fibonacci of 5, you calculate Fibonacci of 4, Fibonacci of 3. While you are calculating Fibonacci of 4, again you are calculating Fibonacci of 3 and 2. So you can see that a repetitive work is happening. What we can do, that instead of implementing like this, we could do something like this, where I can maintain two variables. So let's say P, it starts with 0, and Q, which starts with 1. Now what is there? So if somebody asks me first Fibonacci, I will return 0, second Fibonacci I will return 1, but from then onwards what I'm going to do is that I'm not going to do a recursive call, rather I'm going to do an iterative call, because it is straightforward, right? We have to just sum continuous consecutive Fibonacci numbers, right? Then why to do a recursive call? So we will just maintain the last two and we'll keep on moving forward, and then we are going to update P and Q so that it is always the most recent the last two one, and that will give us the answer. Okay, so let's try doing that. So which means that for one and for first and second Fibonacci it is pretty straightforward. For the Fibonacci numbers starting from 3 and all the way till n, I have to find something. Okay, which means that when so what is happening? So what is happening? You see that before this, like the second what is the second Fibonacci? 1. What is the first Fibonacci? This. The third Fibonacci will be 0 0 plus 1, right? Which means that you can visualize it like this: 0 1 1, right? Now the when the most recent is this one, then my two are these two. But when the most recent is third one, then the third one is computed using. So you can understand that, okay, whatever is computed, then from there count that and the previous one. Which means that if you calculated the third one, then account for this. So this is your P, this is your Q. Okay, if you did something like fourth one also you calculated, then your two variables are these two. You know that your P is 1, Q is 1. You know that P and Q keep on shifting. That is what we want to achieve. Okay, which means that if I is equal to 3, then what I am going to do? I am going to do something like this, where I know that I know that the current one is Q, which is going to be my P, and the P plus Q is going to be my most recent one, and most recent one is going to be my Q. So I can say that it is something like this: my P comma Q is equal to. So you just try to understand this. Just so it is like parallel assignment. So you can understand it like P is equal to Q. P is equal to Q, and then in the separate line you can understand that no, actually you have to take a temporary variable. Yeah, so that is the advantage of rather than take. So firstly you have to take a temporary variable, store P there, then P is equal to Q you have to do, and then Q is equal to Q plus that temporary variable. So that whole thing is done in a single step here. So essentially what you are doing is that, let's say 1 2 is right now PQ, then what you are saying is that I will take 2 and 2 plus 1, which means that I will take 2 and 3, and then I will make P as my 2 and Q as my 3. That's it. And that's what you are doing at every iteration. When you reach at the end, which means that when you reach at I is equal to n, right, then so when I is 3, then Q is your third Fibonacci. When I is equal to n, then Q will be your nth Fibonacci. Okay, which means that at the end of this iteration, when you return simply Q is your answer. So now you can understand that without using this recursion, you still get the same answer, and you can prove that it is still 12. Not only it is still 12, you can see that all the test cases are also passing, which means that our solution is working perfectly. So instead of recursive solution, we converted our solution to an iterative solution. Okay, so that is fine, and this should be it. However, in the end, actually I want to give slight more optimization. So basically what we are trying to do is that you can see that you can see that when we are trying to iterate, then firstly we calculate Fibonacci 1, right, and then we calculate Fibonacci 2, and then we keep on summing after, like independently we are summing. isn't it that thing can be done directly here only? So my point is that let's comment all these for now. I am saying that this function can be modified, and for that modification let's comment this also, but we will duplicate it like this, and rather than Fibonacci we will say Fibonacci sum. What this Fibonacci sum will do, that it will not return the nth Fibonacci, it will return the sum till nth Fibonacci. Now for the first Fibonacci and the second Fibonacci, the sum and the number itself is same, because the sum is 0 and number is also 0. And then for the second Fibonacci, the number is 1 and the sum is also 0 plus 1, which means that 1 also. So both these are fine. But after that, what we can do is that we can maintain a variable sum, right? And right now, so when you are done with till the second item, right, then sum till second item is what? Is q, 1, essentially 0 plus 1, right? And now I'll keep on modifying I'll keep on modifying this sum, which means that as soon as I get the third, I get the third Fibonacci number is what? Q, because whatever is the I, that is the ith Fibonacci number calculated at the end here. Whatever is Q, basically that is whatever is variable I, that is ith Fibonacci number, right? That is what it is. So what I will do is that I know the previous ones, then I will simply add the current one. Understand? And then after that, at the end, I don't need to return q, I can directly return sum. So what it does is that it is not giving you simply Fibonacci number, rather it is giving you sum till that Fibonacci number, right? And if we proceed like that, then we can see that now I don't need this iteration at all. In fact, directly my answer is, I could export that also, but you can understand that directly my answer is this. I don't need to do this manual computation to do this, right? Let's try that out. You can see that done, which means that all the test cases are perfectly passing. Okay, and as expected for the case for 6, 12 as expected. So now you can see that this solution works perfectly, and yeah, you could use the previous solution also or this solution also, but both of them are equivalent, and more importantly it is passing all the tests which we want. Okay, so any way you process, that is fine. At least don't implement this recursive solution, because this is somewhat inefficient in case of Fibonacci numbers. Any iterative solution or like this sort of direct summation, both of them, any of the approaches should be fine. Okay, so that should be all for this video. See you in the next one.